Yeah.
Hi everyone, I'm very excited to host Theodore Galanos, my favorite guest on this show. I think this is our third time I'm hosting you. So Theodore, as we all know, the expert in AI AEC in our industry, and I wanted to touch base with Theodore. What are the new trends going on for people who are curious about AI AEC and want to learn about the new models coming up, the thoughts, and what are some mindset we should be prepared for this upcoming AI progress. So thanks a lot for being on the show.
No, thanks for having me. It's great. It's great to, yeah. I'm always keen to discuss this stuff, and yeah, it's a lot of fun discussing
I,
this
s-
stuff.
I see. So last time we discussed about semantic AI, your work on text to building floor plan generation. Like, how is that going on? Uh, do you have any thoughts changed from what you were working on, and now you want to?
Yeah. So it's still it's still ongoing in a sense. I don't know if when we discussed there was a proper site and deployment and all this stuff. Like this stuff, it's still there. There is a few other interesting steps that are ongoing and some that are planned. So like the base idea is there, which was very important to me. And like initially, like of creating a design with language, right, or designing with language. So the base thing is there. I'm just now trying a couple of things. One is maybe like publish something in some form so that people can have a reference, like they can read or see evaluations, how does it work and all that stuff, next steps, future steps and ideas, and then finally share the model and the data set, which will happen when I publish. And the other stuff is like a lot of like extensions. So there is quite a few extensions in my mind. I try to not not develop everything together because I want to finish the previous stuff. But yeah, there are some interesting extensions. So I've done, for example, planning. Like in general, what I do, like because there's a lot of developments in AI, as you said, and every other week, like things come out or like trends begin to develop. I'm trying to sort of follow those trends. Architects, I think it wasn't really ahead of the curve in AI, but it was quite initial in semantic generation. It was cool that something in architecture was one of the first applications in AI. But there are so many other ideas that I'm just following because there are so many researchers brilliant. And so like I'm trying to do planning. There were a few papers that trying to do like planning with language models, kind of like yeah, just imagining future actions, future steps, which is very easy to imagine in a design setting because design is a series of steps and decisions, right? So that seems to be working. So like I think I've trained a couple of models that can do planning. I mean, by planning I mean they learn a couple of actions like create, move, rotate, this kind of stuff, and they can go through a series of steps to generate something. So that kind of worked, and there is other stuff like there is I still haven't done the decision transformer stuff. So like sort of reinforcement learning, but like upside down reinforcement learning they call it. So which also is very interesting. So yeah, it's ongoing, let's say. But the interesting part, and I think I've presented this a couple of times. I think in the beginning where people saw it doesn't look very nice, like all these boxes and how they connect this whole design intelligence future. And the even architects, which I really like and I focused all these months, it's just like one little piece of that puzzle. So there are other things like completely outside of it, other ideas that you know i'm I want to develop. So I do have a roadmap in mind
Hmm.
of like what areas we can discuss about what a bit like of like what we could do by short term means like right now, like someone could right now pick up something open source online, right? on the web and just develop something. This there are a few of those capabilities. And then like midterm, which means if you put like a few months of effort with a small team, you can have a product. By product, it doesn't have to be a company, right, or a product.
Mhm.
It could be something you deploy for 100 designers or something, right, for your team or whatever. And then long term of how do we go towards design intelligence. So like there is a roadmap for that. I can talk a bit about a few points, let's say.
Got it. And correct me if I'm wrong, you were using like multimodal models for that, and with DALI and uh, at fine tuning that model. So we know DALI 2 was released, and I'm curious, like if we were to like do similar effort from that time till date, are there any new models which you would replace in your architecture, or is there anything you would modify in the workflow?
Yeah, with respect to architects was not multimodal, so it's not. I started with DALI. DALI was mind blowing in the beginning, and especially Eclipse. So that's where architects started. And the problem became very quickly that images are not very useful for design. They are useful, like as design artifacts or like creativity, and very useful for art, right? But not very useful if you want to make like structured outputs, like I don't know, a layout or some facade panel or an a neighborhood or a master plan. Like it's not very useful if you have an image. It doesn't help. So I went to language models, and there are a few things that I want to try. There are a lot of like new ideas since then. So for example, I'm using quite small language models. Uh, Quite small. I mean, I think the largest I train is a few billion parameters. It's not very big, but the 20 billion GPT Neo was
Mhm.
published like a couple of months ago. So I would love to like fine tune that, for example, on architects or something like architects. And of the other thing is like there were a few models with retrieval. I think this is very nice for design. I tried it a bit. I created some sort of retrieval database and then tried, but I really like how uh, I think was it DeepMind who did the retrieval paper. They use it for generation, so like I think that's very useful because it really reminds me of how design happens. Like in a way, like how you're starting to do something and then you sort of retrieve ideas, right? You're saying, okay, it's the same idea of like going to a knowledge database, maybe in your mind or maybe in a meeting of people in a company, and you bring in those ideas in the new context. That's how retrieval works, and I'm really bullish on retrieval. I think for the future, and they use it for generations. So like while you're trying to generate something, you can retrieve relevant things and add it to the content. Anyways, like it sort of helps generating new things. So that's something that I really want to try. I'm just halfway there because the retrieval paper that came out then, it was very difficult. Like the architecture is, you can tell is like a lot of moving parts and very difficult. So I'm still waiting for to mature in a bit. For DALI 2, like yeah, I mean it's amazing, and it's an evidence of like what scale can do. Like everything I'm doing so far, like they are not really, as they say, yeah, scale built, let's say. They are not very scaled. Like because I have a few TPUs and from Google, and maybe like not even GPUs I'm not using. So you can go up to a point, but scaling all this stuff would be quite interesting. And that's what DALI does, I think. Like of course it uses actually smaller. It's not scaling. It's also like architectural innovations and diffusion and everything. But I still don't think it's there when it comes to what I want to do for design. It doesn't mean it's the only thing that what I'm doing for AI in design, right? I'm just a bit more, you know, I want to handle like kind of engineering aspects or like performance based aspects. And I think for that, like there's different kind of multimodal stuff that we can use. And yeah, I don't know if I answered the question. I lost myself at some point, but yeah, there's a lot of new state of the arts, let's say, and there are some. The nice thing is there are also some initiatives going on to like open source, because DALI 2 again, it might be an API at some point, disclosed
Mhm.
source, but it's not that big in reality. I think it's like DALI 1 was like 13 billion and this one is like 3, something like that. It just has a very large data set and I think like thousands of 100 days of training. But there is a couple of groups that are trying to create like open source. So when we have that, if we had an open source DALI 2, I think definitely I would suggest people from design just diving in, like try to see what it can do, and or maybe fine tuning your own, because maybe I don't have the a proper purview of its capabilities right now. The second uh, version.
I and like what are your suggestions? Because like when you go to OpenAI, like, and you can test models like DALI or Codex in on their website, but how to start that thinking about how can I translate this immediate use case which they have shown on the website to AEC? How to think about it?
Yeah, I think it's not very easy. It's not very easy because like immediate applications of AI or machine learning, they are not very difficult, right? Especially machine learning. You can take an Excel sheet, a spreadsheet of something. You can do some regression or random forest or whatever. Like you can do this stuff. Like, but when you go to like deep learning models or what we call AI, I guess it gets a bit more difficult because I think you need to sort of rethink of the problem. It's not just like let's get a bunch of data and do it. Data are very important, or is very important, but it's not immediately, I think, evident what sort of data you would need, and so there is a lot of exploration there. For me, I don't know if it was an intuition or luck. It was kind of both. Of like, hey, would this work just with language? So the big leap that I did personally was that representing geometry with language. It's not right now. After you do that leap is quite simple to do a lot of things, right? I tried as a test in layouts, but you can try in anything. As I said, it can be like a city, or it can be like, a column, right? It can be like, I don't know, structural engineering if you want. It can be like a bridge or pipelines, it doesn't matter. So I think it really needs to, the first step is sort of to rethink the problems that we have, because I don't think like there are not many immediate solutions that have like that much value for design. Not for the AC. For the AC, we have a lot of immediate solutions. Like you can get off the shelf language models and make a knowledge database in your company, and
Mhm.
that's very useful, right? People can search something and get you get an embedding of the search, and you retrieve relevant stuff from your regulations. That's amazing. That's incredibly useful. Immediate. You can do it like in a few lines of code, but it's not really designed yet. So for design, I think the first step is rethinking like the problem, what you're trying to solve, and how you can imagine it, in a way that you can, when it comes at least to language models, which are at this moment the most capable, let's say, models, how can you express it in a way that they will understand it, right? So I think that's the big step. Language is very good for that, for me, at least in the niche stuff that I've tried it. Yeah. It won't be for everything. Like the next step, obviously, is multimodal, because like as long as language is there, image is useful. I think the image will be useful, and perhaps you can use it. It's always okay to put like new sources of like new inputs to get like better trained models, better understanding, maybe composition, all this stuff. But I think, yeah. So that's how I think you would approach it. The other like standard thing is like find the problem you care about. I've
Mhm.
said this 100 times. I don't need to repeat. Like it needs to be something you like. Like if it's not something you like, it's not going to work. I think. But after you find something you like, then try to rethink it. Like rethink it in terms of like how can I approach this? Like maybe not even with respect to AI. Maybe with respect of like how can I rationalize this problem? And very importantly, how can I abstract it? I think at least for the level I'm working on, like on more conceptual exploration, design exploration, and that kind of thing. How can I abstract it in a way that I can, you know, express it to these models, scale it, efficiently evaluate it, uh, you know, generate it in a diverse manner, all this kind of stuff. To do that, you need more abstract concepts than what we have, I think. And it was hard for me initially because, like most people, or in computational design, I was trained within Grasshopper, right? That's what I was doing. And Grasshopper is really good in what it does, uh, really good in what it does in computational design. But it was a hard step to sort of disengage from that and think in different terms. Yeah. So I
God.
don't know if you answer. Yeah.
Yeah. It helps. Last year we saw like in CVPR there was like first workshop and like competition focused on scan to BIM, and this year I think they are doing again. Like, what are your thoughts on like scan to BIM AI models challenges? What are some models one should keep an eye on?
Like I think it's very interesting. It's obviously like high value activity. That's why I had a workshop, I guess. I do think is one of the things that I mentioned before is a short term thing in the sense that you could probably make a scan to beam or whatever 3D pipeline that sort of works, by downloading some open source model and deploying it. So like it's quite immediate. You can do it, and probably you can do it just by high quality cameras as well. But anyways, so it has value, I guess, because everything at some point in all the projects, everything has to become BIM at the at least where we are now. So I think it's quite valuable. It's something I don't really do.
Mhm,
I would say like I am interested in the 3D domain, but more like like maybe radiance fields and stuff like that. Not really. Or let's say if I was to create pipelines to to create like 3D outputs. It wouldn't be to make BIM models, but I can see the value. I can see the value. I would say though, like I'm not sure, like at least I haven't seen, unless there are people doing it, right? Probably proprietary and they haven't shared. I don't know how good. Even though there are open source models that can do it, and segmentation is really good and accuracy, like all of this stuff, it tends to be on benchmarks. And I don't know, is there any benchmark for big models? Like, do we have more than 50 or while we need like 5,000 or 50,000 or millions? Yeah, so like I would be a bit doubtful to how good it works on a eh, how good it generalizes, and that's the problem with using like AI for detailed design. I think it really needs to generalize very well because you want to do detailed design, right? You don't want at that point to confuse a window for a door or something like that. Like it's not going to work. So yeah, I think it's a very nice direction. I think you need to take advantage of the new technologies, like very very good cameras, very good sensors. Ideally, those sensors will give you directly a model that you don't need AI, right, or too much AI. But yeah, I think it's a good direction. It's just why a direction I'm not currently pursuing because,
mhm,
like I said, I think it's both like low hanging fruit in a way, but also quite difficult. And this is personal opinion. I'm not sure if it's part of what will push the field
mm,
to the future in a way. It's a solution for the present, right? So especially since I'm not yet clear on the relationship between AI and BIM. I'm not yet clear if it will be an organic cooperative relationship or something else like or if AI will but it's good. It's good to have this sort of approach. It's just something I'm not very into yet, I guess.
I was saying, like I was trying to compare. Like recently, I was coming up with like a open metaverse project where they're using OpenAI model to do procedural quest generation, where they can parse metadata of various scenes and then do quest. So I'm thinking, what if we can extract the building metadata, and when I'm parsing like a 3D geometry, I can say get me manufacturer A with this bathroom layout and like on that scale.
I think it's definitely possible. Like I remember Mahmoud, like he had a paper on like beam to vec and stuff like that, like extracting embeddings, data embeddings from beam models, and you could use that, right? I think Facebook had a very very nice paper recently with this sort of data to vec or something, like a huge thing they're doing, a self-supervised thing, like sort of creating huge embeddings of all their data. So you could do that. That would be very useful because it's again something more abstract than a BIM model. But as a metadata itself, like if you want to generate and retrieve, I would just retrieve because you can just. This is maybe this is my own bias, but at that point you don't need AI. I feel in a way like the AI at that point in the metaverse, the way I understand it, I would use it to create the world, to shape the world,
Hmm.
to detail it afterwards. You can sort of detail it in a tabular way. I have some metadata. Okay, all these walls give this family. Like this material, this. All this stuff. I'm not certain it needs. You could have some model on top of that later to sort of like classify and select appropriate groups of materials. Yeah, but I think the generation part would be before that and in a more abstract manner. And I think there was this tweet. I don't know if you saw it, like where they used GPT-3. Just they prompted right, and they prompted it to create 3D worlds, and it created 3D worlds, an actual 3D. So like it didn't come up with I don't know, I forget if it was GPT-3 or Codex. I think it was GPT-3, and it literally they were creating procedural worlds, so like 3D rendered shapes and stuff, just through something like GPT-3. And I think that's where the AI part would be, in creating that initial world and then populating with things. We can do it, or we will have like some routines procedurally to do it. Uh, yeah. So, but it's interesting. The metaverse, in the sense, if I understand it correctly, in the sense of like at the generative side, I'm interested in that. I haven't looked a lot in the other stuff. Like, I'm not sure I would be, opening a company in the metaverse and people can visit, this kind of stuff. I won't ever do it, I think. But I will try to create technologies to create worlds in virtual worlds in a way. I think that's quite interesting. Yeah, that's very nice. Plus, it's a nice world to experiment inside,
Hmm.
environment to experiment.
Got it. And I'd like you to explain, like when you say using GPT-3 to create 3D world, like from the understanding, like GPT is a language, like you get input text, you generate output text. So if you want to create 3D world, like do you attach the output of the language to a content generation pipeline, which takes the text as input and generate 3D model? Like how do you design that?
Yeah. So let me see if I can find it. I think it's here, right? Yeah, yeah. So is it this one? No, this is 2020. I do think they combined it with. I'm trying to find it because this tweet was it was really sort of mind blowing, but I don't know how to. So how it would happen? Of course, it would be coupled with something that. So, for example, something like 3GS, right? 3JS, or some sort of like code, right? Of course. So it's not like GPT-3 can make with words, like it's not like ASCII art or anything like that. But it would literally be create like, I don't know, a 3D world full of buildings. You would describe it, and I think that's what the person did. And out comes an actual 3D environment you can view and move. And so I think that's how it happened. The immediate representation, yeah, it goes from language to code probably, or some sort of structured language, and then it becomes something we can ingest into things. So that's how it will be, and that's why the language is so powerful, because you can express. That's why alpha code is like, and codex are so powerful, because with language you can sort of describe what you want. You get a code, and that code does something in the real world, right? So I'm really, yeah, and I was really shocked, and I don't know if I can find it. I will see if I can find it later and show it. It was really cool. Yeah.
Yeah, so like just to be clear, like in GPT-3, like one would be giving example, like generate a cube text prompt, and then 3JS a scene generation of a cube where with the code. So you give bunch of example and it tries to understand to generate like in a code level. Then you can extract it with a renderer. Oh, I think your mic.
Sorry, I muted because someone was passing. So you would have a prompt which is natural language, and maybe or maybe not you would put a bit more context into it. Maybe start writing in JavaScript, or maybe give some comments, right? I want this in 3JS and I want this sort of functions, and then the language model would do the rest. So like I do think it would create like the 3JS code. It would sort of retrieve stuff, whatever it needs to do, and I will literally really try to find it because it was a really nice example of. I was a bit impressed because it is kind of like impressed and a bit like I wasn't like depressed, but it was sort of like, oh, cool. So you just prompted GPT-3 randomly and you did something like architects, like. But that's the cool
Mhm.
thing. That's the power of language models, right? Maybe I sat down and fine tune, smaller models to be good at this, right? But the really large model, you just ask it nicely and it does it without fine tuning. Zero shot, right? This wasn't fine tuned at all. It was just like some prompt. So that's the power, I think, because if and when we manage to make this available to more designers, then what can they come up with? That's the interesting question, I think.
Got it. And I'm thinking like so I saw a lot of examples using people using OpenAI codecs to create like 2D games, and like it was like using all the GitHub code. So they had like a lot of content that understands the context. If if I were to like design like we have like a search space and a problem space for our architectural solution, how would we architect to do like a design space exploration using GPT-3?
Hmm. So that's a cool. That one goes back to the roadmap I was saying. So in a way, the way I've structured like design, it has like certain like areas, like certain sections or like certain. So there is the part of like search that you mentioned. So in there, first of all, not everything is AI, right? In there, you have like generative design and generative models. It can be, Revit, Dynamo and Grasshopper or something else like Houdini or custom code, right? It can
Mhm.
be procedural. It can be also like deep learning generative models, like for example, it could be something like architects, right? So you have that part in search. So you need like to search, you need to generate. This is the first thing, at least in design, right? In many other fields, you don't need to generate to search. You can just search through the 5 billion images in the Lion dataset, right? But we don't have 5 billion designs. So to search, we need something that can generate. And then you need, because we are doing design, and I think generative design by itself is a gimmick. It doesn't really do anything. We also need evaluation. So we also need to understand if the design is good. So that at that point you need like surrogate models, because you can't really do evaluation at a generative scale. It's just too expensive. So you need to, whatever metric everyone is, people are interested. Some people care about cost, other people care about carbon, maybe like weight or load, other people about daylight, doesn't matter, but you need something that can quickly calculate that. And by quickly, I don't mean like I move my slider and in 1 second is there. 1 second is way too much, right? Because we're talking about scales of millions. So a few million seconds, you're already at a year or a few years. And then, yeah, and then to do exploration, if you have those two parts, like something that can just generate or even plan, like you can ask it, okay, I want to do this, give me 10 alternatives, 50, 100, right? You can do it hierarchically or not, doesn't matter. And then you have something that can take all these things that come out and instantly, in a way, evaluate it. Then you can do general exploration, design exploration. That's how I imagine design exploration. Like, it's not like, I go through 500 alternatives for my slider. That's not generative design. I think that's parametric design is okay, but generative design, at least at the age of AI, should be like me, pure. And at that point, we can use quality diversity. I think it's one of the perhaps the most approachable areas of AI for design, because everyone I've shown it to, I've shown quality diversity from AEC, they've all sort of understood it immediately because it's very, it makes sense. How you structure your design space, how you search, right? How you focus on novelty and not on performance and all of that. I think quality diversity, once we have those two pillars of like generate and evaluate, it would really be a very important tool for the AC, right? Because it can really allow to explore, really explore the space. And yeah, so I think it's definitely possible. And it's very nice. Those three parts are a small part of the roadmap again, but I think they are very very nice area to work on. Yeah, if people are interested.
Got it. The challenge I foresee is like having like generative design, like it's possible. The challenging part is like you might be covering some part of the whole design space, and you might induce your own biasness or like your
Yeah,
assumptions, whatever generative model you have, and there might be a better solution out of your whole generative space. So like I don't know like how
exactly. Yeah.
to evaluate that.
Exactly. I mean, by definition, parametric design works by adding biases. That's what we do. Like that's literally the definition of parametric design. Because the minute you sort of start creating your ranges in your sliders, that's your bias. You're biasing your design, right? The minute you put like maybe like your classes of like, oh, this is good, above this is very bad, below, the minute
Mhm,
you say like, oh, forget how much was it, 60%, GFA has to be above like this lux, like to get a lead certification. You already bias your design, right? So the parametric design that we do is you're completely right, is biased. And this is without mentioning our cognitive biases, our experience and intuition sort of bias, all this stuff that we bring with us in design. Quality diversity is nice because it sort of like systematically helps you escape all that, right? It starts from the very simple idea of like goals and metrics are the enemy. This sounds very weird, but that's the whole idea of like the more you chase something, the worse you're going to be doing. That, he has a whole book about it. I will share it later. But there is also like I think very nice expression of that in Goodhart's law. Like I think some economists from the '70s and they call it like Goodhart's law, where like every metric that is used, every metric that gets optimization pressure, like stops being a good metric, right? It stops. So, and this in design is very easy to visualize. Imagine that you want to make a design and you're optimizing energy. You really optimize energy, right? If you do it naively, what's going to happen? Okay, I don't need any windows, like perfect, no losses,
mhm.
nothing. I'll just put, like in this sense. Of course, this is naive extreme, but it happens very in nuanced ways in parametric design because of the way we bias and we focus on metrics. Quality diversity says no metrics. Just tell me how you want to explore, right? Which are the directions you want to explore, and you incentivize to explore everything in those ranges. Of course there are still ranges, perhaps that you can go infinite, right? But at least you're not telling it, and then you have a quality, that's the diversity part, and then you have a quality that is sort of your metric but without the pressure to achieve anything. It's just cataloging the quality, right? I just keep a score. And every time I find a better one, I replace the old one in a way, right? At the top. That's all. It's a very simple idea, brilliant, and I think it would let us explore like really beautiful design spaces. And I think it will be one of the first things I truly deploy with. I'm hoping to deploy it with something like architects and something like infrared because those are the two pillars. And that's how I started my work in all of this. I started filling in these gaps. So infrared was the first gap of surrogate models. So that approach, like, can I evaluate in real time? Architects was the generative gap. Quality diversity will be the exploration. And we have the search workflow done. There's more downstream, but so yeah, that's how I imagine search in AI and design. If that makes sense.
Got it.
I will share some links somewhere. I don't know, LinkedIn or here, some keywords or
You
something.
can also like share screen for briefly if you want. Yeah.
Yeah. Okay. I will do later.
Mhm. So now I'm like comparing various generative models one could integrate. So there are auto regressive model where you can just give one prompt, it can complete the whole story. So one, that is one area. There is also like reinforcement learning, where I can define my explore exploit parameters, which can also affect the design space a lot. And we have like this GAN based exploration. So like what are your suggestions, like what type of generative uh, algorithms work better for our case?
For design, right? Like, I really think I'll go back to qual diversity. I think these population evolutionary approaches they work best.
Mhm.
Uh, they're sort of like gradient free approaches, let's say, evolutionary, right? So you just search because a lot of our problems are discrete, or at least we need to discretize them to be able to create stuff like I guess you could like continuous optimization, maybe like meshes, like optimize a mesh or a hull. That's
Mhm.
interesting, but again, it's not the kind of problems I care about. So I care about more discrete stuff like buildings or spaces, right? So I think like, yeah, the qual diversity approach I would do. Like RL is good, but the way we use it, I've said it a few times, like the way I've seen it used in AC is like just as an optimization approach, just as a very good optimizer in a way, and not really searching. But there are some really cool, there is some really cool work lately in like planning and all this stuff. Like again, language plus RL, all like reinforcement learning guided by semantics. So I think that will be very interesting for the AC for design because you can imagine maybe like I don't know what type of agents exactly. They could even be like agents that inhabit spaces in order for us to evaluate the spaces, right?
Mhm.
But it could also be other stuff, even for construction, whatever. And you can sort of teach them and guide them through language. So, and in a way, we can do that because our environments are, like you said before, we have all the metadata. You can explain the environment in structured language very nicely. This is a wall. You know the texture. You know the material. You know the height. You know the distance. So that's what people have been trying in a way to do this sort of language guided RL. I really like it. But yeah, I think just this evolutionary, but it's a more like next gen evolutionary. It's really simple. It's not like, but I do think is really better than. So not just a GA. I ran a GA in Grasshopper, right? The GAs are very good. Like the QD, the quality diversity, it's even simpler than a GA. It's super simple. Like there is no actually algorithm to optimize. It's just the previous part, the generation, that is the very important part. But yeah, I would use quality diversity to explore. I wouldn't use guns. No way. Like first of all, guns are. I mean, we can say they are dead. Like they are they are not better at anything anymore. I guess the only thing they do better is domain adaptation, like image to image stuff, something like that, right? But anything else, diffusion has won. So maybe
Yeah.
people do diffusion. Diffusion sounds nice for exploration, for like because everything is based on noise. So maybe you can perturb things and create different geometries, for example, or different designs. But I don't think it's going to be diverse enough, like this sort of models for what we need. While if you have a model like that, and then quality diversity driving that model, so like where to generate it, how to generate, then you really will have very powerful exploration. So that's how I would do. And yeah, the Arela would keep it for the next step, which is like, what do you do with the design space? Because, and I think this is very important. I think that most of the questions that I ask with AI is that what is next? Like I try to ask it every time because things are moving so fast. Like you can't really get stuck on one thing. So what do you do with the design space? If you could press a button and you get 1 million alternatives, nice structured, what do you do with it, right? So this is a nice question. Like, do you just take that and go to a client or to your colleagues or to you show it? Yeah, that's cool. It's nice. People will like it. It might help. But could we use it to do something? Could we create data sets? Could we train like design assistants on top of that data to help us make decisions later, so I think the RL will be there. I like the RL at that point, in sort of like designer modeling, I call it, in sort of like creating agents that model our design preferences, and then they can really help us while we design. So that's
Yeah, I could foresee like some AI to be like design space explorer, then like curate some design. There's like human level of design curation and like one filtered check whether some of the solution makes sense or not, and like present it. When you were
yeah.
saying about RL with semantic, I was just thinking like RL can like one could uh, make a model where it could have like various 3D spaces, like move rooms, create bathrooms and stuff. And if we can have like a render or like take a snapshot of like image rendering of a scene from a particular angle with various modulation, and then have like image to text description how this space looks like. So the thing I'm trying to do, can we have like RL plus semantic to have like subjective evaluation of a space, and maybe that is also driving RL to explore and exploit.
Yeah, I mean, subjective it depends because you need a subject for it. Like, so you still need to be, who is the subject of that space in a way, which ironically it's not. It's almost never the center of design, which is the occupant. So like, but what you can do, I guess, with Iranian language, I do have a paper that I like. I was reading it the other day, so I will share it very fast. Let's see if I can share the screen. Just the screen, yes. So like it's this one here. It's called improving intrinsic exploration with language abstractions. Okay, it doesn't matter like if it sounds complex. It's really simple and powerful idea on the surface. Is something like this. So this you can imagine this being like an office, right, or a house. Doesn't matter. And what they do is they utilize language to describe goals, right, and things the agent can do in the environment. So and the cool thing is that they have a model that sort of creates goals and chooses what goals to do and trains the agent. And slowly, step by step, the agent learns to do more complex stuff, right? And beat these games or these environments. So if you think of this in, and I will probably stop showing it now. If you think about it in design, like, and as you said, you might think of like maybe you have it create again either like some goals, like what do your occupants want to do in this space, right? Maybe they want to work and go to the bathroom, I don't know, meet other people, like, have a quiet area, they can, all these kind of goals. And instead of like hard coding everything before, you could have something like this that sort of discovers goals and trains the model on top. So I really like this approach because they are using the richness of language to sort of like train something in this manner, right? In self-supervised manner. And you could imagine this while you're doing design, because instead of saying go to the green door, maybe you say, a house with this many rooms, or this type of rooms, a house with this, these connections, with these adjacencies. Doesn't matter, or an office with for this many people, right? With these quiet areas, these open areas, like it can be, you just communicate it to the agent. And then let me stop sharing because this is so like, and it turns out from that research, which is simple but very powerful, I think, that it's just better than not having language. So I really think that this can work in design, because you see all the environments they're using, they're sort of like kind of design. I know they look like mini grid, and they are, but it's a top down layout, right? It's very, we can do a lot of stuff with that. That's the cool thing. We don't even need 3D. You can do a lot of stuff. You can represent the real building as a top-down 2D layout where people move. And so, yeah, I definitely think is you can use it to both learn and explore, like find new things you can do in the environment. You can use RL and language, and there is yeah, there's quite a few papers that are trying to do that. I keep saying papers, and I wonder how people in our field understand this. Like a lot of time, I have to make this footnote that please, this doesn't mean is some crazy person in the clouds talking. In the AI domain, papers are actually they're actually products. Like it's very hard to communicate this. Like, oh, a new paper came out, and people like paper. So what? And no, it's just that model. You can download the code. There is a checkpoint. Everything is so it's literally, yeah, it's hard to explain. But just I want to make this footnote that when I say papers, I mean like state of the art things you can use right now most of the time. Like not everything is open source. Yeah.
I'm wondering what if we also like that's a good practice in AI world. Maybe for AEC, if we are presenting any computational paper or AI paper, it might be a good practice to share the model and data along with the paper so other people can develop on top of it.
Yeah. Yeah, I mean the architects. That's the idea. When the paper is out, I didn't want to do it before because if you do without a paper, is without a write up, it's like there is a lot of problems. Like people probably are not sure how to use it. They don't know the limitations. Even right now, when they're using it on the side, they're like, I want a villa with a pool, and the output, of course, has nothing to do with that. And like, why? Because there is no write-up to explain, what is the
Yeah.
data set, what are the limitations. So yeah, but definitely we should open source things. And but even though in this case the data set is not very important, initially it was just a grasshopper script, right? Creating data. The methodology is more important, but yeah, it will be open source. And I hope we do it. Like this, the other thing I was thinking the other day, like how to convince. I think I will try, and I think I have a good chance to convince people to sort of open source. Like I think, for example, there is a huge opportunity for a company right now to become, the first company that has a whole profile in Hugging Face. You click, you search their name, there is 15 models underneath with model cards, with data sets, papers people can download. Like it's a huge asset, right? It's a huge asset because it not only like creates awareness about what you do, like you become famous in other domains and all this stuff. You can attract talent, which is really difficult nowadays, I think, right? You can have other people use your work, which is again is like people are helping you develop. And it's never like, it will never be like, oh, I gave them the secret sauce. That's the other thing about AI. Like every 3 days that sauce is obsolete. Every couple of months it's just obsolete, right? Like so yeah, I think there is a potential there for people to understand like who's going to be the first one
Hmm.
that will just open source everything. And I think whoever does it, they will see the value. They will see very quickly the value you get back. But yeah, personally, I will share the dataset like a version. It's a very augmented, weird version of the dataset and the models, and people can play around. It's nothing difficult.
Yeah.
Uh, yeah.
By the way, the paper you showed is quite interesting. Like, I'll definitely check it out later. Uh, my next question is, for in PyTorch 3D world, have you seen any like interesting development in that area which we should keep an eye on?
Yeah, I mean, I have a whole folder with 3D. Like I can open it. We can see like I do have a whole. Again, people will see folder with papers. Yeah, this is just the state of the art stuff. At least where I came. So let's see the folder. Like still, I'm not really like I don't know. Like, let's go to my folder. Like modality, and this is the 3D space, right? There's a bunch of stuff here. Like I don't see like apart from like nerf. And I'm sorry, I keep showing the. Apart from this nerf, let's see. Like oh my god, what's going on
Yeah, yeah.
here? I can like the rest are like like yeah, okay, here the SDFs, you can do some mess stuff. There's some really cool stuff like Facebook actually published a real-time SDF renderer today, which was really cool. I thought I have it here, I can bring it. Is this one here? So this stuff are really cool. So this is, remember you were saying like all the scan to beam, right?
Hmm.
So this is a scan to beam. So this is like a differential renderer. So you just move it around the space and pop, it gives you a 3D model, right?
Hmm.
So this is even after scan to beam. You have this model that can directly do it, right? With no software between, with no data exchange, messy, with no like processing, pre-processing, just directly. end to end create a 3D model. So this stuff are really cool, I think. It's not what I currently do, but I think they're really cool. They have potential. So you can see here, like, they just go in front. You see how they just, with the camera, with the RGB and the depth, they create. It's pretty amazing, right? They create a 3D model here, like a literally 3D model. So this stuff are really cool. I think. Let me hear. No, I miss it. Like the nerve stuff, obviously, are very cool, but there's just not something here I think that I really, really like personally, right? This is my, maybe the special, these representations are nice, like how to understand space and representations. Those were good. And there is some still here, like this scene representation.
Can,
I like this
can
stuff
you
here.
zoom a bit?
How
Like
you?
it's difficult to
Yeah,
read.
it's very hard.
On
I will
the-
open some, like this sort of stuff are interesting, but still, this is my problem, right? This picture here is my problem. Like you have an image and you do some segmentation, and I don't care. It's just an image. It's useless. Like it's just an image of pixels, right? So
Hmm.
I want structure inputs. Personally, I don't care, right? That doesn't mean everyone, but it's just not my thing. So on the 3D domain, I would say, like, point clouds and stuff like that,
Mhm.
in creating, as you said, scans to 3D models. That's very powerful, and we can do it without AI because we have very good hardware as well, right? And maybe you have some AI models like this Facebook one that you can, in a self-supervised manner. This means, like, I don't need to train it every time. I don't need, it's just, it just looks on millions of, like, synthetic environments. It learns how to reconstruct them, and then I take my camera and I do this, and it gives me a 3D scan directly, right? But maybe you can do that with a nice, more expensive Matterport or whatever, or a Leica, right? So that area is nice, and of course, again, the metaverse. But at least I don't know if I'm wrong in this, like, because when I speak, like, people from the AI domain, when I show them my work, it's usually, oh yeah, what about 3D? And isn't it like, I don't know what architects think because I'm not an architect, but isn't like 2D already 3D? Like, I don't separate the two, right?
Mhm.
When people see the layout, okay, it's a layout, but like this, I can extrude it, right? And very simply, I can cut holes and make windows and doors. Like, it's already 3D. The difficult part is creating the morphology, right? The connection, the connectivity.
Mhm.
All the rest to make 3D is just simple, I think. Like, I can extrude, I can cut, I can put materials. Like, all this is super simple. And with things like Unreal, right? It's real time. So that's why I'm not very into that personally, because I think the hard part to solve is this language to design, right? To some space. If we can manage to make it end to end, and it creates a 3D rendered world with just a sentence, amazing. If it creates like a 2D world, I sort of post process, okay, I can do that, no problem. But this semantic generation is the key, I think, and not really how the end result, the post processing is much easier. That's why I'm not so much into the 3D domain. Not for any other reason. I could be wrong. Like, as I said, this changes every month. So next month, maybe someone comes up with an end-to-end model like DALI 3D worlds, and I'm okay. Bye. Like, I'm all in. But up to now, I'm just not into that yet.
Yeah, and it's also like important to consider that like this 3D world has like a lot more parameters than 2D. So you might have like 3D generation pipeline with less intelligent model, or you can have highly intelligent model on a 2D level, and you can post process
Hmm.
to have like better results.
And I really think, anyways, that this design is a very complex activity, right? It's like NP complex or whatever. I don't know if it is actually, but so I don't think, maybe someday will be end to end, but even if we can, I don't think that's how you get the most value. I really like this hierarchical approach of, like, in a, like modular, sort of like separated but also connected. So, like, some components do this, some other components build on top of that and do this, right? Do another task. And in this way, I think we will much quicker create an end-to-end pipeline, which is an end-to-end pipeline of many moving parts, not many. Ideally, not many, but and as we move forwards, yeah, some of these parts will merge and we will get more in. But I really like this hierarchical approach to design because that's how we design, like, at least now. If we manage to end everything, then yes, a lot will change. maybe architecture offices won't be there, and people will just type a sentence, and a 3D model with drawings and everything, and submissions comes out. I don't know, but we are very far away from any of that, and I don't even think that's even the nice direction to go if we want to change how we design, right? Because that direction is kind of like, oh, how can I replace everything? Like, I don't like this sort of approach to AI. How can I replace? It reminds me the automation. Okay, automation is very nice, very powerful for now, but for the steps in the future, you also have to think of like, how do I change completely? Not just automate this task, but how can I design without this task, with some other task, right? With some other way, yeah, with another. So
Yeah.
that's what I am. There's
Yeah.
some.
Let's take some questions from the audience. So, like,
Sure.
one thing I wanted to mention, like, so in the conference last year, I saw like embodied AI category where like they have like scene understanding for robots, where even like you can say identify that box object and move from here to here in the space. And I think that's another interesting area, like if people are reading about it, to look on, which might be
Definitely, yeah.
useful in AEC context.
I'm on record, I think, in a couple of places where I said that RL is a gimmick and it doesn't work and everything. And I've changed, like I said, it moves very fast, right? I've
Hmm.
changed my timelines with that. I think RL has made incredible leaps in the last 4 to 6 months because of, I think, because of this language embedded. But now it's much closer to being like you say, like you can do things with it, right? You can, maybe not in construction. I don't know, like it's too too messy like we do it now. Again, we go back to changing things, like, oh yeah, robotics for construction, and people think like we're gonna have the same construction site and just some robots building. It cannot. We will have to think of like, we need to build different things, right? We need to build them in a different way, in different places. Anyways, I will rant about this, but yeah, I think RL is becoming, I think, way closer to ideas being practical, and yeah, definitely people should research it. I cannot. It's I even if I try, I don't think I am managed, but there are so many other people smarter than me, so go for it, please.
Yeah, so we have a question from Sanjay. Can you give any names of GAN algorithms you most? So I think it looks like very open-ended
Use, right?
question.
Yeah, so gun, I mean, I don't use gun anymore at all. I think the last gun I trained was style gun, just to make funny buildings out of some images. But yeah, I use like language models. I can name a lot of models, but the easiest thing you can do is to go to Hugging Face, and I don't know how to type in the chat. Is it the
Uh,
private chat? No, right?
it's on the sides.
Hmm. I don't see anything on this. I see the chat, but I cannot reply. Anyways, it's okay. So Hugging Face, yeah, exactly. Thanks for writing it. If you go there, they have about, I don't know how many thousand by now, or hundreds language models open source. I've used, to give you some names, like all the GPT language models there, some others like Bert or Bart or Roberta. I don't know. They're all like names of characters, but yeah, that's what I use most right now, language models. And for guns, the best one now, I don't know. I guess the VQ gun, was the best one
Hmm.
and the biggest impact, right? Because it's still being used in a bit in art generation. So that would be something. It's also open source. But yeah, if you really want to look into generative models, I would look to diffusion models. So glide is not. There is a small glide people have trained. There is a lion model, diffusion. There are a lot of notebooks, open source, you can get with those. You can make amazing stuff. I really like glide, the paper itself. When I saw it, it was the closest thing like to generative model in the image space that could be useful for design for me, because they have this thing in the paper. I can show it actually very quickly.
Hmm.
But it's okay. OpenAI. Cloud OpenAI. Yeah, it's this one. So, so what I liked a lot, I'm just opening that. I have it downloaded, but I just reopened it. I like that they have again this progressive sort of editing. This again, as I said, like, stepwise manner, like do, and to do that, you need to allow the model or your tool. This is no longer a model in my eyes, is a product. So this model by itself is a sort of software, right? So you need to allow it to have like much more refined control over the input. And Glide did that, and I really like it. And DALI has the same capability because it's actually Glide more or less scale. Uh, and I think like this amazing compositionality that people find in DALI, where they say, make this with this, really comes from Glide, and it takes forever to load. I'm sorry, but yeah, they have this area, and it's very architectural. That's why I want to show it, and so I will wait just half a minute, where they edit a house, they edit a living room in
Oh.
a and. So if you really want for architecture image generation, I would go to diffusion models. Perhaps get the open source Glide that exists. I don't have a link handy, but there is one, and then train it on some of your data or fine tune it on, you know, interiors, for example, right? It doesn't matter. Okay, it's on. So let me. Am I sharing? I'm not sharing. Yeah, okay, so people
Mhm.
didn't see me load the paper. So this is the paper, and very quick again, paper, right? It's actually a software, a product in a way. Literally, this became a product 1 month later, the DALI 2. So these are the generations, but the cool thing is not this. Like you can do some nice stuff. Okay, this is part of what you can do. So you can see here, right? I want to put zebras here, so you put zebras. I want to put a corgi or whatever, right? I want to change my hair, right? And all this stuff. But the cool thing is here. Yeah, here we are. Very architectural. So you give it a prompt of a cozy living room. Oh, this is very nice. But can I have here a painting of a corgi? Yeah, sure. But here, is empty. Could I have a round coffee table? Sure. And then here on the table, can we put a vase of flowers? Right. So this is a few things in one image, right? First of all, it shows that what I was saying before, these papers are not real papers, they're actually like descriptions of an actual product, right? Practical thing. Two, this model is not just a model, it's a literal software. Like to do this thing, right? Either you put it online and you pay someone to change the 3D image for you, or you do it procedural. In a way, you have some sort of software, you do it. You can imagine doing this on a 3D space as well. It shouldn't be that difficult, I think, eventually. So like it's really a design product, right? And the third, of course, is what I was saying. Like this is not hierarchical, but it's like sequential, like sort of sequence of steps that I want to do. And this is another area where I like language. Like image models can do this, which is really cool. Language models can learn from all these sequence though. So if you can imagine that just imagine that you had this model and it worked on the 3D domain, and you had like hundreds of designers using it just with language, creating interior layouts, for your clients, for everything you want, right? For metaverse, doesn't matter. And then you were storing these interactions. You were storing all this essentially prompting, this language prompting, these prompts here of language. You store them. And you also store the outputs. What is the difference from here to here, right? Then you could fit all these interactions to a language model, to something like a language model, which will have also image model, and you could learn to do a whole interaction. So this is why I think language brings so much, because this model can go from one to the other using language, of course, right, very easily. But you could also learn from this whole sequence. Anyways, I'm rambling a bit, but yeah, it's quite amazing. This paper was really nice, and it's quite amazing. And this was my favorite image. Like when I saw it, I was like, okay, this is actually really practical, right?
Mhm.
Something I think I told people from the AI communities that yeah, people from my domain they can really relate to this. I think they should. Here the wall becomes a window, right? And even the reflections, it's just insane. Yeah.
Yeah, like I think like first time when you tweeted that language models are gonna be like have a big role in architecture, like I was not like I think it was year or 2 years ago you did, but now like with all the applications and like use cases you're showing, I could literally see like a big potential. And one thing I am foreseeing is, so currently, if I'm not wrong, like diffusion model have higher inference time compared to GAN, but it would be great if let's say architects are in a client meeting and we can do this like modifications real time where we're making changes
Yeah,
instead of going back office changing the 3D model coming back with a new render.
definitely. Yeah, being inference being fast is very important. Yeah, I have a couple of thoughts on that. One is get some GPUs. Like we need to invest eventually in GPUs. Like literally, with how the economy is, anyways, right now, like it might be better to like buy GPUs than just have it in the bank or something like that. The money, or like just buy it because they just go up. It's like wine, right? So, but eventually we need to invest. Like I'm just thinking out loud here, but I can think of hundreds of companies in the AC that would really gain by just buying a DGX, just buying a whole DGX. How much is it? $200,000. It's like peanuts, right? For some people some companies that you know, it's not peanuts. It's a lot of money, but for companies with very large budgets and very
Yeah.
large, uh, cycles and all this stuff, it's not really a lot, and you can make so much out of it, right? So there, one solution is that just you know, buy, invest in GPUs, and you can then in real time do everything you want. The other thing is that there are a lot of people that are working on diffusion specifically. Like Catherine Crossan, I think is the best right now probably in the world. Beating a lot of labs, and she has a method I think that works really fast. I think even like 5 to 20 steps, and it samples like really good. So it's quite fast. It's not yet real time, no. So that obviously is an issue, like in the sense like it's not going to be pop pop pop. But in any way, it's like I don't know if eventually will be, but even if it's not, it's still valuable, I think. So
Yep.
maybe at the moment, it's just the important aspect might be the human computer interaction. Like, how do we design the interaction with this software? I quote the software, but they're actually, I really think they're software. But so maybe until we get this real time, we can design our interactions in a way that are not hindered by this sort of 3-second interval or whatever. And if we survive the 2-minute interval of virtual programming and grasshopper dynamo, every time you move a slider you wait
Hmm.
5 minutes, then we can survive like a few seconds, right? But yeah, those are my couple of thoughts. Things move very fast, so we went from like 500 or 1,000 sampling steps to like 10, right, in a matter of a few months, with probably similar quality. And two, yeah, we need to invest in some infrastructure to train and deploy models.
Yeah, I was thinking like people invest in real estate for inflationary purpose. There might be a time where people will just invest in GPU for inflationary
Yeah,
asset.
yeah. I mean, maybe people are doing it already. I don't know. I'm not very good at that, but I would imagine is a very good investment. Is so good that you probably cannot buy one. You have to wait for 2 years to get it delivered. So that means it's that good, right? I don't know if it's
Mm,
2 years, but you have to wait to get a GPU. Like us normal people, like we can't really buy a GPU. It doesn't exist, right? Unless you want to pay 3 times the price. So yeah, I see George is asking. Hi, George. Also, it's been a while. Nice to hear from you. Yeah, I think the next step for CL and infrared will be thermal comfort. It's been on the works for some time, but yeah, I think it will happen eventually. It will happen. And thermal comfort is something I think a study that I like because it happens very rarely. When I was doing it like 4 or 5 years ago, I think I was the only person doing it. I don't know, like at least like at the level of that. Of course, there are thermal comfort like experts, but at the level of like I have a small site plan or whatever, a master plan. I didn't know anyone else who was doing it, and I think it's really impactful because it shows you exactly again not the occupant of the building, but pedestrians, and really like relates to people on the ground. So yeah, that would be the next one. And I think one of our goals is to sort of create an aggregate metric because some people get lost in the metrics sometimes. Like it's not very easy to follow or understand. Actually, it makes sense. Like if I tell you, oh, 50 hours of danger here, like, okay, so what does this mean, right? So we want to make an aggregated resilience metric, kind of like how many places in around the world have. So Yeah, it will be UTCI. I mean, that's the state of the art. So yeah, UTCI based. The method we're not sure yet. I mean, it will be eventually a deep learning model predicting it, but yeah, there are some steps before that.
Yeah. I wanted to know your thoughts on about the Tesla AI Day. I think that was pretty interesting. They have some cutting edge reveals, and one of the thing they talked about was for automated like vehicle navigation, moving from raster image space to vector image space. And uh, just curious, what are your takeaways or thoughts on having this kind of navigation in that space?
Yeah, I mean, I'm not nearly an expert or not so green in SVD. Let's say, but I do know that Tesla has sort of like bet on no 3D sensors, right? No lidars, just camera and self supervision. Like, so I think their models are just trained on billions and billions of images, right? Self supervised models, and then those models are then fine tuned and used for planning and execution and driving. So it seems that most people, maybe because they like Elon or maybe because they know better, believe that's the best approach, and that cameras are becoming so good, that, and the models are so good, the depth models and vision models, that we don't really need lidar. But I don't know who's going to win out. I imagine yeah, like, as for the vector, like, I'm not sure what that means. It's like maybe, yeah, I don't remember that exactly, but I do know that they have bet against lidar because mostly I think it's a business decision. I don't know, like, this is my naive idea, because lidar is just too expensive, right? And the cost of the car, like, and they are selling cars, all right, already. They're not like trying to sell in a decade. So I guess that's what they are doing. What I liked about their presentation was obviously like the dojo. Dojo was pretty crazy. Of course, they're not using it for to train AI models, just to train Tesla stuff. So a lot of people were happy about that, because it's a lot of compute that is not used towards AI. Because one of the issue we didn't discuss, like, is alignment, and it's quite important. And I feel it's still very fringe in AI itself, but I can imagine how fringe it might be in the AC, and we should discuss it because these models are becoming so powerful that they do and will have issues beyond bias and ethical stuff, right? Which are already very important, right? They already have like very bad biases. They regurgitate stuff. They, if we don't do proper work on data collection, or even like the reason why we build them, they will sort of recreate our biases. But they also have problems that they become more and more powerful, larger capability, and that's kind of scary, right? So if you can imagine a future, not AGI, but let's say a capable AI model, capable, I mean, that take actions in the real world, and imagine it in a design space, right? So maybe is running a building, right? You've seen it in a sci-fi or whatever action movie, probably. Is this computer that runs all the systems of the building, right?
Mhm.
And usually, it goes bad and it kills everyone. But that sounds naive. But with these models, it's not like some demon will be created and kill everyone. It's just that these models, they might not be aligned to what we want to do, and they can be misaligned in very peculiar ways. Like, maybe they will be misaligned because they are trying to do what we told them, right? Oh, save energy. Okay, I will shut down all the ER monitors, because they, like, very naive again. But I think the alignment is quite important and to discuss. And the reason I like it is because two reasons. So this is very out there, but hopefully maybe someone catches it and follows through. We don't know how to do alignment. Not we. Like, the very, very, very smart people, like orders of magnitude smarter than me, who are trying to do it and push it, they don't really know. There's no theory yet of how to do it, right? People are just exploring, experimenting. So that's one. Two, there seem to be quite a lot of funds in alignment, in the sense that if you are very serious about alignment and you sat down and read and had an idea, describe it well, you probably get some funding from the many sources out, right? Probably, I'm not saying for sure, but it's much more than if you want to do like some sort of climate change hackathon. The third is that I believe that the applications of AI might be a good test bed for alignment. So again, maybe we have a simulation, right, where we put these models in and we're trying to understand how they would act in the world, right? By acting in the world, it could be how do they design, right? And alignment with respect to design could be, is this safe? Is this buildable, right? Is this efficient, right? Is this dangerous? This kind of stuff, right? So they would be very nice test beds for alignment, I think. Interesting test beds. Because right now, most of alignment is like, let's take language models because they are the most capable models and look inside. That's very important because you have to understand how they work internally. But I think equally important might be, if I take it in the world, how does it act? And then you can also look, sort of understand the insides from the outside interaction. And maybe this is my suggestion to people here. Architects or designers in general could be very good alignment researchers because of that. Because they have a very cool application, the real world or the simulated world, a building, a city, doesn't matter, like a robot. And then you can sort of create a test bed for this sort of explorations. And in this way, maybe get some funding and do some research. So I really recommend people to just Google this stuff. Check for, Less Wrong and Alignment Forum and like all these competitions and like and see if you're interested. I do think that we do have something to offer, not at the theoretical level maybe because that's
Hmm.
very out there, but at the how can I test some things is very important right now, and that's my suggestion. I've been thinking about this the last couple of weeks of like maybe why not? Why maybe we have like this to offer to this very big problem, right? And at the same time, you also do progress because you're trying to create capable models for something in the AC. Yeah. Sorry, I
Interesting.
I diverted there. Yeah.
No, that's like I haven't delved deeper into alignment, but like your point makes a lot of sense, and maybe we should have more open discussions around it because like awareness is one of the important aspect. I have one last question on. We had a brief chat in Hyper Discord about how can we have open AI codecs to like for design space and briefly like we discussed like we can use XML to have like a like from Grasshopper script
Mm.
which can understand the
Mm.
sequence, and we were thinking like what's the right data format, data structure for the model, like what are your thoughts, and like can you give us like uh the
Yeah.
context?
Yeah. I think the first time I came up with that, I forget what it was. Like maybe like 3 years ago. It was before architects for sure, but it was close to there, very close, because I was already thinking of like language modeling and stuff. And yeah, I mean the idea is quite simple. Like I, maybe people have done it already. Like if someone has done it, tell us. It's like all the Grasshopper scripts is just XML files in a way. Right? You can literally right click it and view the XML. Probably I forget. I haven't.
Hmm.
This is my admission for the last few months, maybe a year. I haven't done any Grasshopper, right? Because yeah, I focus on other stuff. But they're already XML. So like yeah, I ideally they have a lot of structure tests. You would need some structure text in there, right? Everything is there, like the component names, the inputs and outputs, the graphs of where they're connected. So all the structure is there. So my idea was maybe we take thousands of these, right? And we use metadata, whatever metadata we have in there. That's another problem, of course. Like these interfaces, they were never meant designed with language models in mind, right?
Hmm.
So the metadata is not in a format. Oh, nice, I can use. I have all this text in there I can use, but we can still use like component names, component descriptions. You can maybe get like descriptions from the code, right? You can use the file names, maybe notes, all this stuff, and possibly like because it's very large context, cut them in groups because anyways that's how it works in Grasshopper. You have group, 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 right? And my idea was that you can do a few things with that. First, the simplest thing is you can do some embeddings, like just train some models on top of it, and then this group sort of embed them in a vector, something like that, and then you can retrieve. So, you could, for example, autocomplete components in Grasshopper with this, right? By autocomplete, I don't mean like when you press the name and the search comes, but like when you put a component there, you know how Codex shows you the continuation, right?
Yeah.
You could see like maybe you can do it in Grasshopper. That's the nice thing. You could do like a faded continuation of the components. You
Yeah.
could do, right? And then you can tab and boop all there, and it would work because more or less the structure doesn't really change for some stuff. I've done and redone like infinite times like specific components. I feel like, of course, there are simpler ways than this. Maybe you do MetaHopper like Andrew's thing, right, where you save, but it's not that general. MetaHopper, you need to save and save and save and save. Okay, but this might be something general where you get like continuations, and maybe you can choose a different continuation. Maybe some novel thing comes, right? So that was the idea. It's still out there. Like it shouldn't be that difficult. It's the same thing. You get the data set, you post process it a bit. You do need like some sort of pipeline of like something the model sees. You can start by raw. Just take the XML, pass it to the language model, and hope. It will work, but it will be messy. Then you need to like clean it a bit. Then the model creates something like that. Then you need to translate it to something like Grasshopper will understand, and somehow deploy it within Grasshopper. So there is some work there. But the idea is pretty straightforward. It's just that I never got around to do it. I think it's pretty possible though. It would be like Codex. Like for those that use Codex and you're in VS Code and you type something and after a while, a gray continuation. Imagine the same in Grasshopper. Like you just put a component and there is a gray continuation. And how long that continuation is relates to the context of your model. I would just do like a couple of steps. I wouldn't, you don't really need to have very large context. So that's the idea. You can also do retrieval and all the other stuff we
Mm.
discussed. Yeah, but that's the idea, and I think it's a very cool idea. It's a nice project, like for someone to do.
Yeah.
On that.
And like I'm just thinking like is like my comment like I want to, let's say, make a stair, is the text prompt in Grasshopper is like a autoregressive command, or my like pulling down a pointer component, and then like how do I get the next steps for inference?
Yeah, I mean, to get it by prompt alone, you would need a dataset. So there, you would need some work because you would need to like have someone. You could always take the file name, but file names can be very like ugly also. But what you would need there, and eventually we will need that. Like we will either need put like people like us becoming mechanical Turks in a way, like Turks. Not Turk, I'm sorry, it's the TURK, right? It's not it's the Amazon stuff. I don't really like that word, that expression. And either we become just like literally sit down and do the work, right?
Hmm.
Of like, okay, this grasshopper file, I did it 3 years ago. What did I want to do here? You need to do that. Or maybe you start and you take a group of 5 components and you sit down. Okay, what is this for? This is heavy work. It would be a lot of headache, probably a lot of man hours, but they need to happen, right? Or you create some sort of best practice of like how I create grasshopper scripts, right? And from now on, your computational design team, as much as possible, follows this sort of best practices where metadata and language is very important. So explain to us always now. Because I don't expect Grasshopper itself to do that for us. It would be nice if Grasshopper itself has a way to do it, right? But yeah, so ideally the component will work because that's the easy data that we have. We have components and connections and relationships from the XML itself. So if you start with a component, from the point of view of the language model, it doesn't see any component, no image, no wire, right? The component is just a prompt of XML. And then it just gives you some continuations, right? Some of them will be like overfit to what it saw, to the data, which is good. In design, by the way, in computational design, overfitting is not bad, always. Why? Because we very typically we want to do the same continuation, right? That's what we want to do. So maybe it's good to continue it as we always do, right? Or and sometimes if you also plan and you use the model to prompt like 10 different, and diverse continuations, you can find new stuff to do. So you can imagine this as a learning tool, for example. Maybe people just put components. Someone is learning Grasshopper, they just drop a component and they see like 5 different continuations. Okay, I take this one, then 5 more, I take this one. And at the end, if you can have an end, they have something that does a task. And they just their task after is to understand how this works. It would be a nice learning tool, for example. uh, Better than what I did with like Grasshopper in the form, like this too. So yeah,
Yeah.
that's the idea.
And like literally like every day, when I use OpenAI Codex in Visual Studio, like sometimes it gives me more efficient or cleaner way to execute a particular intent. So like if someone is defining a geometry, like even the best practices prompt can save a lot of computation or efficient way, or maybe alternative ways to solve the same problem.
Yeah, and the cool thing about Codex, I've seen a lot of tweets and examples of people like, you get very different results with how you prompt it. So prompting, we said before, I think is a whole science and a new job of the future. So yeah, how would you prompt it? And that's even interesting, right? If we had a model like that for Grasshopper, then suddenly computational designers would become experts in prompting this kind
Hmm.
of models. And I guarantee you, like, even like a few months later, a few weeks later, you would get like novel things generated because of someone found a way to put the components in a specific way to create something new. Right? I think that's very exciting. The same way people are creating better code by prompting it nicely, right? By putting a bit bigger context. Yeah. So yeah,
Yeah.
definitely. And Codex, I mean, I'm not like a developer. I can code, but it helps me in a way in the very menial part of the coding stuff. Like when I need to, and also helps me like it's sort of like I don't need Stack Overflow. Like, oh, okay, design. Give me the minimum graph distance function. But and immediately it gives you instead of googling it. So it's really helpful. And why not? Like it doesn't always need to be like again. I go back to like this image generation, general image generation. It's beautiful. You can create art, but sometimes we might need simpler things that are very time consuming as well.
Cool. Yeah. It might be interesting, like if someone has like parametric stairs and then another prompt is in the form of facade or building, then like it would create
Yeah,
some cool combination.
yeah, yeah. I wonder what you can do with that in the form, and yeah, I don't know.
Yeah. Yeah. So let's do like a rapid fire to conclude the interview. You'll have like 10 to
Okay,
15 seconds and keep it brief. Okay.
okay.
So which three papers are in your top reading list?
Three
Research
people in my
papers.
top reading.
Three research
Oh
papers.
shit. Research papers. So Alpha Code probably. Uh, Sorry, I cannot do. There are so many. Like maybe Palm, the latest. Actually, it's not Palm. It's Optimal Compute. I forget. Training Optimal Compute language models. That was the other one because it showed that you can do much better with less. And yeah, I don't know. There are too many. Maybe this implicit, was something lately. It's not. I yeah, I think those two maybe, but I don't have like top three because they are every week. You know, they change. Yeah.
I am testing your paper retrieval algorithm.
Yeah. Not very good. Yeah, I definitely need retrieval automated.
I see. So my next question is, can you name one of your favorite or top model for language, image generation, and multimodal?
Language GBDJ is really good, both the pre-trained and if you train your own, because the code base is really nice and you can do it on TPU. Image, I mean, I like the VQ GAN workflows and the new diffusion models by Catherine, as I said. Rivers have wings, her Twitter handle for people to follow her. And And then Glide, I really like Glide. It's not open source. Like there is a smaller open source. The best image models are not open source. So Glide and DALI, I guess, DALI 2. And you also had another one, language image.
Multimodal.
Ah, multi-model. Yeah, okay, we said already. So Glide probably,
Mm,
or DALI 2. Image itself, yeah, Style Gun maybe. Yeah, I would say.
got it.
Or
Uh,
Pix to Pix. Pix to Pix, very good. Very good. For what it does is still state of the art. Yeah. So
I see. And what are like some ideas you would like to do if you had unlimited time and resources in AC, AI
so
AEC?
yeah, so I want to do alpha design. So I would like to do alpha design. So like AlphaGo, alpha code, alpha design. So I would really like to do it. I want to experiment and see if we can work with like self play and planning for design. I think that's probably the most long horizon. But even that, long horizon, maybe a couple of years, right? It's not like a decade or anything. If you had the resources, maybe you do it in a few months. Not us, maybe some deep mind if they cared about design. So alpha design, I think, would be the top. Yeah.
Got it. And three things you would do to increase AI AC education awareness and adoption.
About education, I'm not sure. I mean, make things available and open source, like knowledge, especially, not the models and stuff. So, like, explain it, how you do it, do workshops, share. For awareness, I think the best thing I can do is bring this stuff to practice, and that's a very explicit goal I have for the near future. And what was the third? I'm sorry, it's getting late.
Uh, Adoption in industry.
Adoption. Okay. So for adoption industry, first, again, you need to bring it to practice. Again, an explicit goal. And second, I think I'm going to focus on sort of like showing that certain things can be very good wins, like in a way, like they work, and I want to prove it. So it's just that. It's just putting them to practice and showing people that they work. So it's nothing very wild. Just bring it to practice. Yeah. Sorry.
Yeah. And how do you foresee metaverse affecting our profession?
I'm not sure in that. Like I don't know. Like hopefully, it will affect it in ways that it will change it drastically and radically, and it won't just be like having our offices in the metaverse and doing everything else the same. So yeah, hopefully, it will allow people to sort of like build their own worlds, virtual worlds, and by doing that, appreciate how design works, how the real world in a way should be designed, or maybe find new styles and new configurations. So that would be the best way, I think, as a sort of design exploration space for humans. Yeah.
Got it. And Theodore, anything we didn't cover in this interview, and you would like to share the message?
No, I think that's all. Like my message always is like telling people that all you have to do to start in all this is just start. There's nothing else. Like you just need to do the first step. And my positive sort of like advice that I tend to close with is that we have a lot to offer to the AI domain and many other domains. It's not just that we just borrow from them.
Hmm.
So please get involved, because this will happen anyways without you, right? It is happening already. So get involved because that's the only way you can steer it to a better direction.
Yeah. When are you starting back the reading paper sessions? That was a great initiative.
Yeah. So I apologize for that. It completely like it was going very well, and then life caught up. But I have plans for very soon after some things move forward to reinitiate the community and the reading session with so once a week and time zone. So that will happen hopefully in the summer. Yeah. Apologies for
Awesome.
something in there.
Thanks a lot for your time and for
Thank
all
you.
the work you're doing for the industry. It's really inspiring to see your thoughts and your progress because uh, we look forward to your recommendations. link on social for sure.
No, thank you for having me. I hope some of what I said was interesting and some people got some threads. Yeah, that's all.
So have a
Thank
good
you.
night. Bye bye.